All right, ladies and gentlemen, let's talk about the last thing that I can actually break down, I think, which is the weakest link in this whole entire building industry. A lot of people just look at wire as just wire, and there's a lot of value behind wire, and wire does a lot for you. So I printed you guys out all new stuff. I even matched amp for amp, okay? And I'm just showing you, and I didn't write on it so you could follow me, so you could understand each single one. And then I'm going to explain the wire. I'm going to go over this pretty fast, this part. You can run your own numbers off the website, like I tell you. Each wire is rated at a certain amp. Like 10 gauges say 30 amps. But that's just a rating. That has nothing to do with distance now. So this is where numbers change. So say you're running a 12 volt system, 19 amps, right? 8 feet long. That's 4 positive, 4 negative. 1% drop, which I tell you guys is what I recommend. That's the only way to get the cleanest energy to your system without wasting it. And then right here, so at 19, it recommends 8 gauge. That's the minimum. Okay? 8 gauge. Not even 10 gauge. Okay? So that's just on that build. And this is your wire. This is why you got to run your numbers. It changes. So now, say we go 24 amps. Remco, right? We ain't even going to add for surges or anything like that. We're just going to install flat. What gauge is this, guys? Right here. At 8 feet, 1% drop. I don't see 10 gauge. I mean, we're already at 6 gauge. So 8 gauge and 10 gauge are a no-go. With 4 feet and 4 feet of wire. Okay? 1% drop. You got to run your numbers, guys. Now we go to 30 amps, just to boost it up a little bit. It stays at 6 gauge. Okay? Now we bump it up because we don't want the wires burning up. Right? We don't want the wires to burn up at all. So we're bumping up our system. Plus it's giving us cleaner energy. The heat in the wires are able to move through it with no resistance. 40 amps. Same feet. I didn't change anything. I left that the same. 1% drop. Look, guys. 4 gauge. 10 gauge is all the way up here, guys. Now, the reason for this, each gauge has an amp rating, but when you run distance, the length is what I tell you guys is what kills you. That's, you keep running the wrong wire. Well, they run it, yes, but they're spraying lawn and garden, and they're running an open valve. When you put a soft wash gun on this, you start to change all the resistance. Remember, the first check is the minimum they require. They were telling you you could go all the way up here to make it even better, because that's where your voltage drops come into play. The smaller the wire, the worse voltage drop, right? So if you run these two types of wire, I know this is speaker wire, but it's still a rated wire. So I'm just going to show you as, okay? When you're running these wires, when you come on and off the gun, do you think you have a better chance with this one keeping your pump cold? Or is this one going to keep your pump cold? Do you think this little guy is going to give you all the power the batteries can feed you? Or are you going to get better performance with this one? If you're on a job and you're coming on and off the gun, creating resistance in your line, do you think this one's going to heat up and start feeding you dirty voltage? And this one's going to allow you to do what you need to do? That's the difference between small wire and bigger wire, guys. This could handle a dirty resistance that you start creating from on and off the gun. This wire cannot. Let alone, some of you are running this 8 feet across. I already showed you guys the numbers. It might work, but you're only wasting your money because you're cheating yourself out of performance and you're cheating yourself out of power to the pump. You're cheating yourself out of good power because you're feeding it dirty voltage with a smaller line, right? If these wires are constantly getting hot, what do you think is happening? They're burning up, right? That's the reason for the bigger wire. That's why they tell you to use the bigger wire. I mean, it's right here. Some of you guys like to argue with me, but it's right here. I'm showing you how to be better. So this is how you save your equipment. Same as wire we're talking about. Same as on your machines. If you have a machine and you don't install the battery right here, right next to it, and you run it all the way down the trailer, that wire that came with it, you can't just buy bigger and add to it. You have to raise the gauge. So if you don't raise the gauge, what's going to happen is every time you go to start your motors, they're going to struggle because they're not getting the voltage that they should be getting to turn over and sound like a beast. You got Wimpy over here trying to turn over because it can't even get anything out of the thinner wire. These are the difference of why you need bigger wire. You're running commercial built equipment, right? Well, build it to last, not to break. And some of you guys say, well, how do you get that flow, Eddie? Wire and 2 batteries. I'm feeding the pump what it needs. That pump is getting more than it ever needs. That's how I get it. Hopefully that explains the wire side. I mean, I really can't explain it anymore. I showed you the charts. I show you what Ohm's law tells you how to build them. I show you all the proof, so I don't know where else I could go. But this is the biggest problem in this field. Nobody knows wire. So, bus bar to the wire, right? Change over to the different size wire to the pump. So, you need your voltage drop test on your wire. If you're losing more than 1% to the pump from the battery, your system is built wrong. Fix it.